everyone. My name is Amrita Bhatnagar. I am from CSE Department of Akgs. Today I am going to take lecture upon the introduction of operating system. So in this lecture we will discuss about the functions and different types of the operating system. So this is the outline of this lecture. Firstly, we will understand introduction to operating system. What is the operating system and what are the main functionality of the operating system. Then we will see classification of the operating system, in which we will discuss about the batch operating system, multi-programming operating system, multitasking and time sharing operating system, and multiprocessor operating system. So firstly, we will understand what is the meaning of operating system, how it is very important for us. An operating system is a software that acts as an interface between computer hardware and components and user. Every computer system must have at least one operating system to run other programs. What it means, operating system is a layer between the hardware components and the user. By the help of operating system, user can interact with the computer hardware. It cannot, or we can say that the user cannot directly interact with the hardware. It needs a software layer which is known as an operating system. It is also known as a system software, by which user can interact with the hardware components. Applications like browser, MS Office, Notepad, games, etc. need some environment to run and perform their task. Example of the operating systems are Windows, which is very popular in this time, Linux, Unix and Mac OS. Linux is a open source, so it is also very popular in the market. So this is the main introduction of the operating system. Now we will see what functions of the what are the main operating system function, or what functions operating system perform. This is the diagram. You can see here in this diagram we have hardware components here, and in the hardware components we have CPU, RAM, input, output. Fine. And this is a layer in which users works. And this is another layer between the hardware and user, is known as a software layer, where we have the different type of software. We can have application softwares, we can have system software, and we can have operating system also. So by the help of operating system, application software can also run, and operating system is also known as a system software, because it requires to conduct the system properly, or by which we can perform different tasks using the hardware. So operating system is a very important part of our system or our computer. It is also a type of system software. Now, main functionality of the operating system. First one is the process management. Firstly, we should understand what is the meaning of process. Process is a program which is in execution. So, we have to manage all these type of processes which are in the execution. Process management helps OS to create, delete processes. It also provides mechanism for synchronization and communication among processes. So, process management a very important activity of the operating system. Memory management. Memory management module performs the task of allocation and deallocation of the memory space to programs in need of these resources. So, we know that we have main memory, and in the main memory we have to give some space to the different processes. So, there is a possibility of task allocation and deallocation. So, this task will be performed by the operating system. So, this is the another major function of the operating system. Next is the file management. It manages all the file related activities such as organization, storage, retrieval, naming, sharing and protection of the file. So, this functionality is related to the file management, like folders and file will be managed by the operating system in the computer. Device management is another important functionality of the operating system. Device management keeps tracks of all devices. This module also responsible for this task is known as a I/O controller. It also performs the task of allocation and deallocation of the devices. So we have different type of devices in our computer system, like input output device, like memory, and different type of devices are we have. So to keep track and to allocate the devices to the particular task or process is also a work of operating system. IO system management. One of the main objects of any OS is to hide the peculiarities of the hardware device. So IO system means input output system management is also a part of the functionality of operating system. Now, next functionality is secondary storage management. It is related to permanent storage. System have several levels of storage, which includes primary storage, secondary storage, and cache storage. Instruction data must be stored in primary storage or cache so that running program can references. Secondary storage management means it is related to the hard disk or permanent storage. So when we have to store the data into the hard disk or we have to retrieve the data from the hard disk, then there is a need of some disk scheduling also there. So this is known as a secondary storage management, and these operations are performed by the operating system only. Security. Security module protects the data and information of a computer system against malware, threats, and authorized access. Command interpretation is another functionality. This module is interpreting commands given by the user and acting system resources to process that commands. Networking is another functionality. The OS provides network connectivity and manages communication between computers on a network. It also manages network security by providing firewalls and other security measures. So we can say that networking means the connecting the different computer with to each other, and they can share the data from one system to the another. So this connectivity can be managed by the operating system only. Job accounting, keep track of time and resource used by the various jobs and users. The work of the operating system is to keep track of all the resources which are performing on the system. So it will keep track of the time and resources used by the jobs. Communication management. Coordination and assignment of the compilers, interpreter, and other software of the various users of the computer system. So communication management is another major functionality of the operating system. So now we have understand what is the meaning of operating system, why it is required for our system, and what are the main functionality of the operating system. Now we will see different types of the operating system. You can see here are the four we are discussing in the lecture, only four different types of operating system. First one is the batch operating system, second is the multi-programming operating system, third multitasking and time sharing operating system, and fourth is the multi-processing operating system. First one is batch operating. So firstly, we should understand what is the meaning of batch operating. This batch operating system was used in the old scenario. Now it is not used. Some computer processes are very lengthy and time consuming. To speed up the same process, a job with a similar types of needs is batched together. So in this case, we will make batches of the similar type of jobs. When a user wants to perform a task from the computer, then it will categorize in the different batches. The user of the batch operating system never directly interacts with the computer. In this type of operating system, every user prepares his or her job on an offline device like a punch card and submit it to the computer operator. So this is a very important thing in this type of operating system. The role of the computer operator is very crucial, because each user cannot directly perform the job on the computer. It needs to contact to the computer operator. Only computer operator will perform the processing job on the computer system, or you can say that only computer operator can submit the job to the computer for the processing. So this type of operating system is known as a batch operating system. So you can see this example or this figure. In this case, you can see here there are different type of users are there, and each user have its job 1, job 2, up to job n, and this is the job operator. So users will give the job to the operator, and then operator will divide it or categorize these jobs into the batches. If the similar type of jobs will be keep in the one batch only, and then these batches will be submitted to the operating system or computer system, and then we will get the output. So this is known as a batch operating system, because in this case we divide all the jobs into the different batches, and these batches will be submitted to the computer system. Multi-program. This is again a very important concept in the operating system. A multi-programming operating system may run many programs on a single processor computer. If one program must wait for an input-output transfer in multi-programming operating system, the other programs are ready to use the CPU. As a result, various jobs may share CPU time. However, the execution of their jobs is not defined to be at the same time period. So, by the name we can understand multi-programming means we can have more than one programs in the main memory. If we have more than one programs in the main memory, then we can give the CPU to only one program at a time. But this, if the particular program needs IO devices or IO requests, then it have to go for the IO devices or IO requests. Then at that time, the processor can be preempt and give to the another process. You can see in the example. So in this example, you can see this is the main memory scenario where we have operating system part, and then we have three jobs: job A, job B, and job C. In this time, CPU is allocated to the job B, because only one job can be entertained by the CPU at a time. So when the job B is ready for the IO request, so it will go for the IO request, where the CPU will not have any type of work now. So CPU will be idle at that time if the job B requires IO request. Now the IO devices work will be started. At that time, this CPU will be given to the another job C, because we want to utilize the time of the CPU. If we kept CPU idle, then the efficiency of the system will be decreased. So in this time, when the job B is going for the IO request, the CPU will be allocated to the another job, which is known as a job C. And in this way, in the multi-programming, the CPU time will be utilized. The CPU will be more utilized than other operating system. So in this case, we have more than one programs in the memory, and it can execute in this way, so that CPU utilization can be increased. Now, multitasking and multi-time sharing operating system. The operating system that runs more than one task at a time is known as multitasking system. MOS can be desktop or mobile operating system. Different tasks run in the OS are MS Word, MS Excel, email application, browser, media player, OS services. End user use all these programs at the same time, but OS take this concept little different. What it means, when we start our system and we start different type of application in the system. For example, we can start our any Word file, we can take any Excel file also, we can start songs also, we can start any movie also. So all the different type of application we can start in our system, then it is known as a multitasking operating system. Now the in this system, operating system will give the particular time quantum to each and every process or each and every task, and every process will be given a time slot to the slot of the CPU. So you can see here, task 1, task 2 and task 3 is given there. And in this case, 10 nanosecond is given to the task 1, 10 nanosecond is given to the task 2, and 10 nanosecond is given to the task 3. So each and every task will have the equal time slice of the CPU. So CPU will entertain each and every task equally. And for example, this task will have 7 burst time. So, or sorry, 70 nanosecond burst time. So, first time it will get 10 nanosecond of the CPU. Then in the another round, it will give for another 10 second, and at the 7th cycle, after the 7 cycles, this task will be complete. So, in this way, each and every process will get a equal time slice or time quantum from the CPU. So, that user think that all the processes are running simultaneously. Now, next one is the multi-processor system. Most computer systems are single processor system and they only have one processor. However, multi-processor or parallel systems are increasing in importance nowadays. These systems have multiple processors working in parallel that share the computer clock, memory bus, peripheral devices. So, in the multi-processor system, we have more than one processor. So, this is a diagram for the multiprocessor architecture where we have more than one CPU, but it can share one memory only. So, it is known as a multiprocessor system. Now, this type of multiprocessor system can be of two types, symmetric multiprocessor and asymmetric multiprocessor. In this type, in the symmetric multiprocessor of the system, each processor contains a similar copy of the operating system and they all communicate with each other. All the processors are in peer-to-peer relationship, that is, no master-slave relationship exists between them. New job is assigned to any processor, that is less burden. What it means, in the symmetric multiprocessor, all processors have same level. There is no master or slave relationship. No processor can give the instruction to the other processor, and when the job comes, it is assigned to the any processor. But in the case of asymmetric processor, we have a master slave relationship. What it means, there is a one processor which is a master and other processors are slave. So, master processor can give the instructions to the different slave processor. So, when the process or when the job came, then master will decide this job will be completed by which slave multiprocessor. So we can say in this case, master will give the instruction to the slave. So, in the asymmetric multiprocessor, master slave relationship maintained, and in the case of symmetric multiprocessor, master slave relation not kept. Okay, thank you.